Okay, yeah.
Hello.
Hey. Is it on yet?
No, it's not.
Alright, so. Crap. This thing messed up.
Oh,
So Damien is. Remember this morning he said, in our first talk, Damien said if he dies, it'd be bad. So it turns out.
hello. I'm Damien.
He's not dead though, he's just sleeping. He feels kind of sick, so he's not coming today. So it's just me and John talking about ASP.NET Core
It's true.
and the future. So this
So
talk is.
we'll commit to all kinds of stuff because Damien's not here
Yeah,
to stop us.
perfect. Good, that's good. So the goal of this talk is just to talk about random crazy ideas that I had and I want to show when Damien isn't here, so I can just like pretend that we're gonna promise it. But nothing here is gonna happen for sure.
Some of it may
A
happen.
few things may happen, but nothing is being committed to. So a few things we want to talk about today. The themes of ASP.NET Core going forward, performance, as usual. We care about performance a lot. Tech and power is a big thing. Native compilation. Have you guys seen CoreRT? Show of hands. Yeah, do you know what it is? Yeah, yeah. So CoreRT is
A secret. We'll talk about it later.
basically a new runtime for native compilation. If you've heard of Project N, it's kind of similar, but it's cross-platform. New standards, you want to support things like JSON-LD, GraphQL, OData. That's not new, but you know. So we want to have first-class support for those kind of new protocols that come out in RS in MVC. Today, it's all very manual, and we want to have more things that kind of like those things up in the future. Non-HTTP workloads. If you watch our talk at Build this year, we spoke about Signaler and ASP.NET Core sockets. We're trying to figure out how to get ASP.NET Core out of the web space and into more non-HTTP spaces for IoT, etc. So things like MQTT and those protocols that you do use for those things. We want to support a model for authoring those kind of libraries. Simplicity. We get a bunch of feedback from both internal and external that it's hard to get started in ASP.NET Core. You have to do the web host builder stuff. So we kind of want to figure out how to make it easy to get started with ASP.NET Core without worrying about that kind of stuff. So you'll see this prototype that was made by one of our developers that's kind of like going from 0 to 60 in like 0 seconds. And and then this question mark is kind of an idea that I had that's kind of dangerous to show, but I'll show anyway because Damien's not here, so we can do some stuff.
Performance.
All right, so tech and power benchmarks. You guys have seen that we are awesome. We were more awesome, but now we're less awesome. So plain text used to be top 10, now we're like top 20.
But we're still
But
good if you
we're
only.
still pretty good.
So how many here only serve websites that are plain text? All right.
One.
Don't hit your database. Just plain text. We're good. We're pretty good.
We're pretty good there. So people, normally brag and say ASP.NET Core is faster than Node, and then they go to show the JSON benchmark, and then we're like pretty far.
We're
down.
somewhere.
It's right there.
Yay!
67. I don't know how far
right.
that is. So the
How
goal
about
is
fortunes?
yeah. So the goal is to work on other benchmarks besides plain text. We spent the first 2 years working on plain text, and now we're focusing on fortunes, which has a database call as well, and we're focusing on JSON because JSON is so important for microservices.
Now, this was intentional, right? You wanted to do
Yes.
bottom up, right?
Yep.
So you start with let's
Server
get
itself.
simple
Yeah.
stuff, and then like work your way up the stack.
The hard thing is you get a bunch of naysayers saying, as soon as you hit a database, the perf goes to crap. So the whole goal is to make it so that the entire stack is lean, not just the server. So we're actually working up the stack. So now we're going towards like libraries and middleware and things like database calls and libraries and stuff like that.
Okay.
So let's go back. All right, so if you've seen CoreFX Lab, and I believe there was a talk this morning about the .NET performance renaissance or something.
Oh, yeah, I wasn't really on that.
Yeah, yeah. There was one this morning, and it was about CoreFX Lab, which is this kind of a place to prototype new ideas for CoreFX. So things that we want to put in the BCL that aren't in there yet. And by the way, Peter is the BCL dev lead. Actually, he's the dev manager for .NET Core. So if you want new features, ping him afterwards. So the whole idea is to incubate features in CoreFX Lab and then have them move into CoreFX eventually when they're like baked and settled on. So CoreFX Lab has a bunch of things, and the current focus is on strings, byte arrays, web servers, those kind of things, lowering allocations in the core libraries. So we're looking at new primitives for things like text manipulation. So that may apply to things like gzip, compression, that kind of stuff. So today we have text reader and text writer. You could think of it as like that level of primitive, but more efficient. UTF-8 string is a big point of tension because on the web, UTF-8 is kind of the main encoding for most things. And by default in .NET, strings are UTF-16, or UCS2 is more accurate. And the problem is we parse UTF-8 bytes, and then we convert them to UTF-8-16, and then we turn back into UTF-8 bytes on the way out. So the whole goal is to figure out if we can keep the representation all the way through the stack. But if we actually
so you're not copying back
and forth and doing transformations. So there's a bunch of different approaches. One is, do we just change the string to be that by default? Well, if we did, it means that when you go to index into a character at position 5, you may have the wrong data. So we can't just turn on by default. So it would be an opt-in flag, or it could be a new type. The problem is then every single string on the planet has to be converted to this new thing. So it's a big point of discussion. It could save half the memory on most websites. So it's a big game, but the issue is that it breaks the entire planet. So do we choose?
So this efficient encoding decoding, you explained to me earlier, part of the idea here is instead of converting to strings, converting back and forth to actually, we get a byte array in over the wire and do encoding and decoding directly against that byte array rather than
transforming and returning buffers.
Okay.
One example is when you want to get a base64 string today, you have to actually pass, to get a base64 encoded byte array, you pass in a string, you can't pass in a byte array, so you have to get your byte array, convert to a UTF-16 string, pass it to convert to base64 to get a byte array back. So that's kind of a wasted translation. So what we want to do is provide APIs that pass in byte arrays and right into byte arrays, so you don't have to actually allocate in the API itself. Today, to do something as simple as convert a GUID to a byte array, you allocate because it returns a byte array, not right to one that's passed in. So we're looking across the top to figure out where we can actually get wins from these kind of APIs.
Okay.
Span everywhere is kind of a, so who here has heard of span? 4 people.
That's good enough.
So span is like array, but it's faster and harder to use. So it's basically a safe pointer. So today a pointer is a pointer and just a pointer. Span is a pointer and a length. And the whole idea is that it's safe, it's understood by the JIT, so it does things like eliminates bound text for arrays. And the whole idea is that it's a more efficient primitive, and it can represent both native and managed memory in the same type. So if all the routines that did encoding just took span, it would work for both native and managed code. Today, as an example.
And so you can pass it, you don't have to allocate back and forth to copy it.
Yeah, exactly. Okay. So as an example, today, encoding takes both byte star and byte array. Those APIs would go, well, they wouldn't go away because that's terrible. But in theory, new APIs would just take span and wouldn't have to have both byte array and pointer overloads. That's kind of the purpose there. So we'd go across the entire BCL stack and say, where can we get wins from adding span to the API surface?
Cool.
Transport and Kestrel. So in 2.0, we did this whole push to make Kestrel be transport-based. So before libuv, so the way we wrote Kestrel was kind of a web server.
Originally, it was on top of libuv, right?
Correct. So we just put everything into one code base. There was no goal of making it layered. So it was kind of just smushed together. And it was fine. It was really fast. It did its job. The whole idea with making it pluggable was so we can plug in different transports like Rio, which is registered I/O on Windows, which is a very fast way to do sockets on Windows.
So for that, you're basically you're pinning to memory, and I believe it can be even on the network card, right?
Yes.
And so then you're you're working directly against that memory on the card.
Yep. So the whole idea with Rio is you can allocate a giant byte array up front, tell the OS, here's memory to pin into physical memory, and then the network card copies the buffers into that memory directly, and those buffers get passed up to user code without having to copy. So
and Rio is a feature of Windows.
Windows 8 and above. Yeah.
But nobody's using it, or
No.
we're not.
No, not really. So the whole idea here is that now in 2.0 we have made Kestrel pluggable. Now we can plug in different transports. So libuv is actually a separate component on Kestrel. So by default, it's in the box and on by default. But if you look at the code base, it's actually layered into different APIs.
Okay. So and then socket transport is actually switching to using the
.NET
sockets instead of the
Right.
libuv abstraction, right?
Right. So libuv, we use libuv because really early on in .NET Core, 5 years ago now or 4 years ago, there was no sockets. Right. We didn't have anything at all. So we had to have something. And libuv did all the work to make it work on Linux, Mac, and Windows, and ARM, and other OSs. So it's a cross-platform native library. And we just used it because it was convenient, and it was good and fast. It does have some issues with threading, so with libv, there's this thing called an event loop, and all operations have to happen on the event loop. In .NET code, that doesn't work very well because there's a thread pool and the event loop, so you have to kind of manage both things. Sockets kind of makes it go away, so we kind of want to go to sockets directly in 2.1 above.
And then plus also with this, like, this makes it simpler to set up on other platforms,
Yeah.
right? Like, because
Exactly.
when I've installed on my Mac, I have to do OpenSSL and
Yeah.
all these other things,
Yeah,
right?
so because we use sockets, because we will use sockets eventually, when new platforms come up for .NET Core, we'll get it for free without having to worry about porting libv, even though libv pretty much is ported to most platforms because it runs on Node.js.
Okay,
So
cool.
awesome. So who's heard
Pipelines.
about pipelines? Like 4 people.
The same 4
Perfect.
people raise their hands every
Yeah,
time.
so this is kind of a low-level thing. Has anyone here ever written any networking code, like reading from a socket, reading from a network stream, reading from a byte array? Okay, more people. That's good. And you know that problem where, like, if you're trying to parse some protocol, you read a bunch of byte arrays from the network, and let's say it's a length prefix protocol, so you read like the first 4 bytes, and you go, it's some int, right? Let's say it's 5 bytes, but you don't have 5 bytes of payload, so you have to store things for later and keep parsing in some kind of queue, right? And to do it efficiently is very hard because you have to pool buffers and maintain those buffers around the place.
So currently we have code doing this in Kestrel, but it's
Kestrel,
like all home, it's
it's all
artisanal
layers,
code,
right? It's Kestrel, the form parser. Any parsing code has to do this kind of logic because you call read async, you pass in a byte array of like 1K, you get 300 bytes back, and you're trying to figure out if an entire frame fit into that payload.
Okay.
So the whole goal with pipelines is to make that easier, so you don't actually have to worry about contiguous buffers and allocations and pooling. So those things are all handled for you. Today, if you've ever written an efficient web server, when you allocate 4K per read, for example, right? Imagine you have a web server that has a million concurrent connections, right? You allocate 4K for that million, and you have, like, I think that's 4 gigs. I don't know. Is that 4 gigs? Yeah, memory. I did the math in my head, but yeah. So 4K per read async. Super inefficient. So what you really want to do is allocate memory when there is data, not when you're waiting for data. So pipelines kind of solves that too. As I said before, with partial buffers, reading data that hasn't been fully parsed, keeping that in memory, keeping it around, passing it around for later. When you pass buffers around user code, you don't know when they're supposed to go away or not. If you ever pool memory and you aren't just doing it byte arrays every time, you have to manage when that is going to go away, because and how do you know that the person consuming the buffer isn't done yet?
Right.
So
when you've explained this to me before, you've got this code already kind of in Kestrel, but it's very specific to the way you were using
the
it.
parser itself, yeah.
So pipelines is kind of pulling that out and abstracting and making it like
General purpose.
right. Okay.
Yeah.
Cool. On to the next.
Next one, yeah. So a pipe is like a stream, sort of, but it's push, not pull. The idea is that you don't allocate a buffer and call read async. You just call read async, and the buffer is handed to you. So it gives you data from the network or from whatever source is being pushed data into. It tries to formalize the way that buffers are passed throughout the stack. So there's a concept of a buffer, and it can be ref counted, so you don't have to worry about who owns it or who doesn't own it. If you up the ref count, and the person that handed you the buffer no longer owns the buffer. So you can transfer ownership safely without having to worry about when things are not being used. Today, that is handled by the GC, but having to allocate a byte array for every single reader write is very inefficient. So you kind of have to get away from that when you're doing this kind of low-level programming.
Okay.
It's possible to append buffers between 2 pipes without having to allocate because they understand ref counting. So I can say, I want to pass data from this stream to this stream without having to allocate, and that's a first-class operation.
So they're
in
both
pipelines.
able to kind of share that access to that memory. Okay.
Yeah. So here's a small code sample of what it looks like to read data from a pipe reader. So the name pipelines is kind of awful. It was called channels before, but it was confusing with like ghost channels, so we kind of called it pipes, and then people were like, it can't be pipes because pipes have name pipes, and then it was like, okay, you know what, whatever, it's pipelines. So this is the current state of the world. It's not done yet, but this is the current state of the world. So you get a pipe reader in, and it can come from file, socket, whatever abstraction you could think of that can push bytes into this reader. And you call read async to get a buffer back, you get a result back. If the result is completed, then you're done. Otherwise, you get a buffer back from that result, and you can just consume the buffer and call advance. So advanced is interesting. So the reason there's an advanced is because, remember the issue where you have a partial payload, but that hasn't been fully parsed yet? So imagine you had a payload that had a length, 3 bytes, and a buffer payload, right? Let's say it said 5 bytes, and you got 3 of them. You can say, okay, I'm not consuming. So the first argument is what you consumed, and the second argument is what you have examined. And the way that works is if I say I saw the entire buffer, but I didn't consume any of it, so in that case, it would be advanced buffer.start, and buffer.end would be what I saw. You can say I saw 3 bytes, but I didn't consume anything.
So next time I say consume, it'll give me those same bytes again,
Yeah.
right?
So read async will wait until there's more data than what you saw to yield the read async call to you. So that way you don't have to worry about copying data from the last buffer, appending to your list, in that tight loop over and over and over.
So I'm like a client of this buffer.
Yeah.
I can say like, hey, here's what I need, and it just feeds me the data when
Correct.
it's got it. Okay.
That makes sense? Does anyone understand that? No?
Did one
Yes.
person here understand
Yes.
that?
Perfect.
Okay, good.
If you were go back one second.
right.
If you were doing the
I
same
was
as
trying to get out of this one.
if you were doing the same as streams, you would pass in a byte to the actual stream, and you would have a queue of buffers that were kind of the backlog for when you haven't processed the entire stream yet. And this is just handling it for you under the covers.
Okay.
So in 2.0, we did this entire push to make Kestrel be pipelines based, and that was scary and fun at the same time. So Kestrel had this. If you guys saw our talk, like me and David's talk, like 3 years ago, it was we showed Kestrel and perf tricks in Kestrel, and we had this type called socket input that was basically a pipeline, right? And the whole goal was to make it so that it wasn't kind of a gross type in Kestrel. It was a first class type that could be used by any library. So it had to be made a little more general purpose, and adding more, making it nicer, made it slower. So I took pipelines, made it a thing, and then it was being incubated in CoreFX Lab, and then we decided to take it out and put it back into Kestrel as a first class concept. And the first time we did this, the perf dropped like 2x and 3x and 4x. And everyone freaked out. They were sending tons of emails saying we have to revert it, and I said, no, it's cool. We'll figure it out. So here's what kind of happened.
So the green line is the new
one.
pipeline space.
So red is the original Kestrel, and green is the new one. So we had a developer take the pipelines and jam it into Kestrel, and it was a huge change. It was going on for like a month. It had tons of test changes. It couldn't be contained anymore.
Right?
People were checking in over his change, so you had to rebase every day, and he was getting super angry and wanted to quit. He didn't want to quit, but he was super angry.
So right at the beginning,
yeah.
it dropped by, like you said, it's half as fast.
So we merged the pull request. We said, okay, it's time to merge it, and the perf tanked. So it went from 1.2 million to 0.6, like half the perf got lost instantly. And then after a few, so his change was kind of like just the first pass, and it wasn't very optimized. So we did a few low-hanging fruit things, and we got to 0.9 again. So like everyone's kind of happy, woo! So it turns out in perf, it's super easy to get that first big jump, and then like getting the rest is like super hard. That last like 5% is like impossible. So time goes by. I don't know if I can point to the screen. Time goes by, blah 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 blah, and then we realize that you can point the first jump.
This one,
Yeah.
to the 0.9 or the 1.16?
1.16. So it turns out we were comparing two different things. The first one had a higher thread count than the second one. So we were like, oh, cool.
So you
Let's
were
make it even.
Right. So you gave the new implementation as many threads as the old
Yeah,
implementation.
so the old one was
Kidding.
using 1, and
Nice.
the second one was using like I think like 10 or
Nice.
something. I don't even know.
Okay.
So then we did that, and we got a bump where everyone was happy, like almost happy again. It was getting closer and closer. And then we had two teams working like every day on HTTP parser implementations. So we basically had this contest. It was like kind of a mini. So who could get the fastest parser? Right. So everyone was like had crazy ideas, but the whole idea was that the test had to pass because people would write bad parsers that didn't actually work. That would like look for new lines and didn't parse anything, but it would actually
That's
work.
cheating.
Right? It's cheating, right?
Yeah.
But no, it's fun.
It's web scale.
It is web scale. So I actually want to show some of that stuff. Let's can you?
Yeah. You want to switch over?
No, not yet.
Oh,
Go to the benchmarks.
All right.
That thing.
To this one right here.
Yeah. So we use benchmark.net. It's a cool project. You guys should use it for benchmarking. Yeah. So this is the benchmark that we added for the parser. So we had a bunch of payloads, right? So we had plain text tech and power was one of them. I can actually show you the actual payload that we used. This isn't a Mac. I can't use this.
Just,
What's going on? Request parsing data. Perfect.
I'll be your IT support.
All right. So here's the. We had plain text tech and power, plain text. This is.
Let me give you your first
Yeah.
pro tip. You can touch
I
the
can touch your
screen on
screen?
this. I know.
Hold on. Doesn't work on mine. We have live ASP.NET, a real site. We have plain text, fake. We have plain text pipeline, which is a 16 requests all in one buffer, and a Unicode request to test some like worst case scenarios. Convert to bytes, and then we have a bunch of payloads. And then we had a benchmark.NET HTTP parser test that basically just had those payloads in different scenarios, and it ran through. So your parser had to pass this test, and to be valid, right?
Okay.
And we had a bunch of people checking a bunch of different parsers, and we ended up with a better parser. So at some point, after the slides,
Back to the slides.
yeah, we were like doing well, and that was the point where the green line was passing the red, and everyone was freaking out and like super happy. Everyone was like, "Oh my god, it's faster! This is amazing." Turns out we had only converted one side of of Castro. This was the input side, and then we did the output, and it tanked again, 0.86, and they were like, "Oh my god." Then we checked the way at it, added more fixes, and then at some point we ended up at where red is 139 and green was like 140 at the very.
140.
If you can see, like at the very
Great success, right? Like
right there. And then the red stopped because the changes got so big we couldn't maintain both branches anymore, so we just like killed the red branch completely.
That's one way to win.
That's what we did it. So everyone was happy enough to kill it. So we all said, it's time to kill the old branch.
Cool.
And it died, and we were all happy, and now we're better off.
Yeah.
Oh. All right. So I'm gonna demo some random
demos.
things from CoreFX Lab,
Well,
so you can see what the future may look like or may not, because this is all just fake. All right. So first of all, the repository is on github.net CoreFX Lab. And it is the, what? Am I not online?
do you have Wi-Fi?
That's where it is, believe me. It's there.
Okay.
And I have it locally. So here is, this is a giant repository. I can zoom in on Windows. I know how to do that. Everyone see that? Yeah? So this repository has a bunch of stuff. System.binary, system.basic64, buffer primitives, dictionary that's like multi-byte dictionary.
Broadly in there?
Yes, Broadly is this is actually an intern project being worked on right now.
Nice.
Pipelines has a bunch of projects. There's libuv, there's formatting. So this is basically just a grab bag of random stuff that we think could be there in the future, right, in CoreFX. And I want to show you first thing pipelines, a pipeline sample. So we have a bunch of samples here. Zoom in here again. I have a custom HTTP client, there's a custom HTTP server, there's a custom like libuv transport, there's a Rio transport, there's just random samples that may or may not work because this has been a long time and bits rot. So let's show the first sample. Let's show a raw libuv pipeline sample. So we had a contributor, I won't call his name. He refactored everything like super awesomely into an interface with an ICE sample. This is like the best thing ever. So I have tons of ICE samples, and this one is the raw HTTP server. I believe it uses. Okay, so the whole idea here was that since pipe is an abstraction over a connection, you could pass in a pipe implementation from libuv or from Rio or from sockets, and it wouldn't know the difference. So the whole base class, the whole idea was that the base class just has a pipe connection, and it parses bytes from arbitrary sources, and it just works, right? So this connection has I have an iPipe connection which has an input and output, and I create a parser for this connection, and I do the what I call the idiomatic pipeline loop, where you read input, check if it's done. If it's done, you're done. Otherwise, you pass to a parser to consume the buffer, and then you get a result back. If you are incomplete, but the pipe is finished, you have an incomplete payload, so you're busted. Right? That makes sense? If you're complete, then you're done. If you're not complete, otherwise you're a bad request. So, and then when you're done, you allocate buffers from the output pipeline, and then you append some UTF-8 text, because that's what this whole thing is. So this is kind of like a text. This is basically the equivalent of a text writer. It's an output formatter, and these names are all just in the air, so don't even like worry about the names or anything like that. But the whole idea is that this allocates like nothing. It translates values directly into the underlying buffer without having to allocate anything, and it uses generics to avoid allocating, doing interface dispatching in a couple of cases, which is kind of crazy, but it works. So I'll run this sample to show that it works. So the build is super slow in .NET Core projects, but that's being fixed in 15.3, so don't worry about it. If you want to know why it's slow, it's because we don't do the thing called the up-to-date check. That's going to be fixed very soon. So if I hit this and yay, hello world, perfect. What happened there? Let's debug through this a little bit. So breakpoint here on read async. Let's see what happens if it gets hit. All right. Let's go in the browser. Go to 5000. Here we are. I have a connection. It is a libuv TCP connection. It implements pipe connection because it's a pipe that has two ends. I read async. I get data back. The result is a read result. And these are all structs, by the way. So there's no allocations here. Here's the buffer. It's a giant request. It's not completed. It's not canceled. Step through it. So I store consumed and examined. So the whole idea is that if my buffer has 15 requests, for example, I'll parse up until the first request is finished, and then consumed will be that 15, and examined will be like the entire thing. So I can, in a tight loop, just parse those requests in the same buffer without having to go out to the read async call. So it's not empty. It's not done. I parse the result back. It's complete. I parse the entire thing. So the whole idea is that parsers take the buffer as input and return two cursors. It tells you how much it consumed and tells you what it examined. So you can imagine every parser on the planet being like this in this format. And then look at the result. If the result is a complete request, then we are good. Then we can, what would it do? Oh, it's too far.
You're writing it up.
Yeah. It's never at the output. We're going to allocate from the buffer. So the whole idea here was that instead of calling write async and having to pass in a buffer that was allocated from somewhere else, the pipe itself has the buffer chain. So you just say allocate buffer from the pipe. You get a byte back, and you can just write into it. And it grows forever. And when you flush, it goes to the underlying stream. When you finish parsing, it gets reset, and then we move on to the next thing. All right. So that was cool. Let's look at a few more things in CoreFX Lab. So the whole idea is that you could build libraries like HTTP client. So this doesn't work, but here's an example of doesn't work at all. Kind of works, barely. Here's an HTTP client handler built on pipelines. So the idea was that you could build a more efficient HTTP client if you just use pipelines as the actual underlying implementation. So here's the HTTP client handler, which is kind of the guts of the actual HTTP client. And it would just write to the pipeline, get, method, blah. And the buffers would be pooled, and you don't have to worry about allocations.
So let me ask you, is this something I would use instead of Kestrel?
No. This is a low-level primitive that you would use to build things like Kestrel. So you build things like Kestrel.
I would build my own Kestrel.
Correct. You'd build your own servers or parsers or whatever you want to build that uses networking stuff.
Okay.
So that's interesting. Let's look at a few more things like the parsers. So if you're familiar with the base64 encoder today in .NET, I believe the API is convert dot to base64 string and from base64 string. And these guys take char arrays and byte arrays and return byte arrays, so they allocate no matter what, right? So you call convert, you want to get a base64 string, you have to allocate a string, pass it in, get a byte array back. That allocates as well.
Okay.
Instead, these new encoders, what they try to do is decode.
Did I see dangerous there?
Look at that thing. It's funny, dangerous isn't unsafe, but it's dangerous.
Which
but
is worse? Is unsafe better or dangerous better?
Unsafe is better, because at least
Okay.
you know you're unsafe.
All right.
This is a method called dangerous.
I like to live on the edge.
So the whole idea is that you have this decode encode pattern where you pass in both spans or buffers, and we write into it, and then we tell you how many bytes were consumed, and we tell you if how many bytes were written to the actual output, and you get a status back that says done, too small, need more data. Oh my gosh, fail. It could just throw. It's interesting. It doesn't throw. Probably save cycles.
So this will allow me to
Incrementally parse something.
Okay. So base 64 encoded stuff without allocating, without
Right. So
converting
the
back
idea is
and
that the caller allocates a buffer from somewhere, some pool, the stack. So I could pass a stack allocated buffer into transform without having to worry about allocations. But the transform method, all it does is it gets handed memory, and it can write and read from those buffers and save what it did.
Okay.
So the whole idea is that parsers have this format, right? So you write an HTTP parser, you write a base64 encoder, it does this. And this is kind of a low-level primitive in this new world, instead of doing a thing like a stream or those kind of things. Very prototypey, don't worry, your world isn't coming to an end yet. Not yet. UTF-8 string, here is the crazy. And it's basically, in this prototype, its own thing.
It's a new type, right? Okay.
Yeah. Span is interesting. So this actually probably wouldn't work for anything in real life. Yeah, so because span is stack only, it can only live on a stack, on a method, a stack frame. You can't store this string in a field or in a, you can't store it. And that wouldn't work for anything, but it's a cool prototype. So yeah, that's a thing. But the whole idea is that you would have UTF-8 strings on properties and on other things like that, right?
So I read data in from HTTP.
From HTTP, which is UTF-8.
I know it's going to be UTF-8. I don't convert back and forth. I
Right.
do all my comparisons and all that.
So you allocate a new string. So for example, right, we parse the path and we want to check starts with something.
So I
you
can
wouldn't
have a
allocate
const,
yeah.
right?
You wouldn't allocate a string to say starts with blah 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 blah. You would just use the UTF-8 string as is, and there would be things on here like starts with, ends with, whatever it would be. And there's conversions to and from string if you want to allocate, so it's convenient but it's slow. And yeah, that's interesting.
I saw sockets too. You've got a sockets demo in here.
Yeah, so let's change gears. And I spoke about Kestrel's pluggable transports. So the idea came from this incubation, right? We had a bunch of pipelines demos, and we added a bunch of transports for pipelines. And the whole idea was, let's do it in our Rails server. So if we look at the Kestrel repository, this is in 2.0. You can see we have Kestrel core, which is the core HTTP pipeline and parser. Kestrel HTTPS, which is a plugin to do TLS HTTPS on top of Kestrel. There's abstractions now, so there's this thing that sits kind of in between Kestrel and all the transport. So Kestrel itself doesn't actually depend on sockets or libuv, it just depends on these abstractions. And there's this interface between those two things. So we now have a Microsoft ASP.NET Core server, Kestrel, libuv, and sockets. And there's this, the transport interface is pretty simple. There's bind async, which is like bind to a socket or bind to a port, unbind, which is the opposite, and there's stop, kill the transport. And there's the main API is this connection handler. So what happens is Kestrel tells, you say like use libuv or use sockets, and the implementation will say we'll create the transport, we'll create the actual binding, and then it will call, whenever a connection comes in from the socket, from the actual transport, it says on connection. And then Kestrel gets a pipe back, and then Kestrel reads from these pipes, and it does its job. So we have these layers split now, so all Kestrel knows is I am going to read bytes from some source, from wherever, right, sockets or libuv. And it has no idea where bytes come from. So as an example, if you look at the sockets transport, which is 4 files, let's compare these two. So libuv is like
Whoa.
this, right? p invokes and safe handles, and oh my gosh, it's a lot of code that we have to maintain. Instead, we can have Peter's team maintain the code, and we can just bind to those APIs. So when there's bugs, we just like file bugs on core effects and not have to fix them. It's better that way. I mean, simple request, right? So socket just implements this iConnection information. It calls onConnection whenever a connection comes in, and it says do receive, do send. Super simple. Whenever any of those tasks ends, kill the socket, await both things, and dispose the entire universe. And always catch exceptions, and don't log. And then do receive, this calls allocate on the actual pipe, the input pipe. It receives data from the socket, and then it calls advance to commit to the actual pipeline. So the interesting inversion here is that from the transport's point of view, it reads from the input and writes. So it writes to Kestrel's input. Does that make sense? It writes to the input. So Kestrel reads from the transport's output. It's inverted. Right? So from a transport point of view, right, I am going to write to your input, and
Okay.
you're going to consume from that thing, right?
Okay.
And then when Kestrel writes to the transport, Kestrel writes to the transport's input, and I read from the transport's output.
Right. Okay.
Right. So that's how it works. All right. So I think that is mostly it. I'll show one thing of it running on socket, so I can just in the sample app make the start project, and then no one can see it because it's super small.
This actually runs though.
This runs. So we did this transport in 2.0. The intent was to make it the default, but we ran out of time because we were trying to make Kestrel edge ready. That's one big change in 2.0 to make Kestrel edge server ready, so you can run it without a reverse proxy. That kind of won over the whole making it default transport. So what happened is we actually test libUV and not sockets. So if you want to use it, good luck. I can just say, but before I had this call to use libUV, and now the options are right here for libUV, and I can say instead of this, I can say use sockets, and there's socket options. So this is pretty funny. I have to show this. This is my fault. This thing. Yeah. Soon. At some point. It seemed future-proof. I don't know. Let's run this. Oh, this is going to blow up. This is going to blow up. It almost caught me. So Kestrel has a new API to listen on ports. If you've seen ASP.NET Core before, you've seen the use URLs method on the web host builder. This is a more tightly controlled server API, so I can do options dot listen on a unit socket, listen on a handle, listen on different things. This is a Kestrel only feature, not an ASP.NET Core feature across the board for all servers. If I run this, you won't see any difference, but you'll believe that it runs on sockets. It's hard to demo. Did it break?
Better say hello
Did
world.
it break? Oh my god, it broke.
If you unplug your screen right now, it's indeterminate. It didn't fail. We don't know.
What the hell is that?
That's why it's future.
If you came to our first talk, I called this thing the virus. Look at it. Look at it. Application insights. What? What?
Oh, you're right. Yeah.
There's a back door.
Okay.
There's a back door. What is it called? Use setting web host defaults dot prevent. I warned them. I knew this would happen. What?
Now who are you going to blame?
So close. Oh. It's not working, but it's not failing that way.
That's right. It's a
Okay,
Schrodinger demo.
I'm gonna try one more thing. One more thing. I'm gonna run it through IS because I don't trust IS. If this fails, I'll blame Damien.
I will accept the blame on his behalf.
Okay, perfect.
Yes!
Ah! Boom. And that is running on sockets.
I always knew it was going to work.
But how do you know it's running on sockets? You don't even know it's running on sockets. But let me prove it. Let me just hit a breakpoint. Then you'll be like, oh my god. I hit a breakpoint in a different transport, which is the lamest demo on the planet.
20 minutes left.
Yes. Okay, let's pour through the other
Talk
slides
fast.
that are completely lies. All right, let's do this one more time. Boom. Works. Awesome. Go, John.
All right.
Slide.
Core RT.
Core RT is the BCL and the runtime written in C# and compiled to native code. Does that make sense?
What does that even mean?
It's pretty cool though, right?
So it's fully-
core CLR
Okay.
is JITted, right? Runs dynamic code, and it's written in C++ and C#. Core
Okay.
RT doesn't have a JIT. It's compiled to native code, and it's written in C#.
Okay.
It's cool.
So the C#, my C# application
Yep.
is going to be
Compiled to a native binary.
completely native binary.
Yep.
So if I run it on Linux, I'm going to be outputting a Linux
Yep.
binary.
Yep.
Okay. So benefits, fast startup.
Fast startup, super fast startup.
'Cause it's
Super,
native,
super
it's
fast
native
startup. Native
executable.
code, very
Okay.
fast. Small deployments. So it compiles all your binaries into a single DLL, a single exe
Wow.
that gets deployed, and it gets trimmed, so you can trim out things that aren't used, and you get a single small deployable unit. Anyone here ever used Go? Once? No, there's no generics. How can you use Go? Yeah, it's pretty cool. So you get the same kind of deployment size, so people are interested in containers and having small deployments, so that's kind of a big thing.
So a problem though, there's a lot of dynamic stuff going on in ASP.NET,
Yeah.
right? So you've
Yep.
got dependency injection, you've
Yeah.
got controller discovery,
Yep.
all that kind of stuff. So,
So basically,
checkmate.
all dynamic things die when you use Core RT or Project N, as it's called in some cases. Has anyone here ever written a library that worked on Project N? UWP. UWP? Everyone here does server-side programming? One person. I don't believe you. I don't believe you. So we had this idea. So to make things work on UWP, you normally have a slow path and a fast path. One that does reflection and one that does ref emit or IL emit to do assemblies. So the whole idea was that anything that does runtime compilation with ref emit has to be compile time now. So the whole idea was, could we convert dependency injection to be a compile time container versus being a runtime container?
So you need
so
when I compile my application,
you have to know
I
at
need
that
to do all
point-
that DI stuff
Yeah,
then.
and it's super
Okay.
hard because things like open generics don't work. You don't know all of the generic instantiations at compile time, so it doesn't work. But imagine it did. Imagine. So I wrote this super hacky prototype at some point in time, and it was so long ago. It was when we had Project JSON-X Proj. This is a while back. This is the old prototype. So the whole idea was a tool would run your application, call configure services, get your dependencies, and then call generate code. So you get a C# file that has all of your container logic. And if you look at my app container, it derives from this new compile time container base class, and it generates these if statements. If services blah, get blah. If services blah, get blah. And then those things we just call you generate code that does new console, new blah, and it would resolve the entire dependency tree in your class, in your C# files, right?
So it's a code generator.
It's a code generator. So you generate all the code for the compile time dependency graph at compile time.
So you showed me before this beautiful code in program CS. Oops, not Project JSON. RIP.
And pour some.
Yeah, I pour it out. So this is what your new
Yeah, so
program-
string append.
Yeah, all right. But the idea
pretty
is
cool, though.
it's
Yeah.
a code generator
Yeah.
that's building this.
And you
this-
do it for controller discovery, you do it for anything that required runtime compilation, would do this instead.
Cool.
So you probably get a build task that ran a built-in that did this and added to your project.
Nice.
All right, that's Core RT and random ideas. So in 2.0 Kestrel, we're going to do HTTP2. That's happening. This is happening for real. This is the only thing happening for real.
This is the only thing you're committing to this
Yeah.
entire talk.
Yes.
Okay.
Yeah. That's happening in 2.0. We're going to get started on that.
So that's native in Kestrel.
In Kestrel, yeah.
Okay.
First class support for HTTP2 in Kestrel. Has anyone heard of Quick? No? Yes? Yes? No?
Somebody.
Hold on. Just one person has heard of it?
Just pretend. We're not going to quiz you.
No, I mean, like, this thing is super obscure right now. So HTTP2 is cool, but it's not cool enough.
We need HTTP.
We need another thing, HTTP3.
Yeah.
HTTP3.
Okay.
So Quick is, what's Q stand for? I think it stands for Quick. Quick.
Makes sense. There's only so many
Quick
things.
UDP
Queen, it could be
internet
Quasar.
internet connections. I think that's what
Okay.
it stands for.
Okay.
And the whole goal is that it is built on top of UDP. So think of it as TCP on top of UDP.
Okay, because HTTP2 is like
Is
serial,
is
right?
a multiplex protocol on top of TCP.
Okay.
So the whole goal was to not have multiple connections for an HTTP connection. You just have one connection, and you can send multiple requests over the same connection.
Okay, right.
So you have streams over that one connection. But the issue is that if one stream is like slow, you'll block all the streams because TCP is reliable and in order. So it's hard to build a scalable protocol that is multiplexed on top of TCP.
And because HTTP2 already was this kind of multiple like
Yep.
request thing,
Over the same
it
connection.
makes more sense to work with a UDP like transport.
So they built this thing called Quick on top of UDP,
Okay.
which is kind of cool. And the whole goal is that it's in the application layer, so it doesn't require a change to every kernel on the planet. So this new protocol, which is coming up and looking really good, is going to be this brand new protocol, and it mixes things from HTTP2, it mixes things from TLS into a single protocol that does like super fast connection time.
So
if
who
you-
understands Quick?
Google,
As
they
a
made
client?
it.
Like,
Chrome.
okay.
YouTube.
Chrome already supports?
Of course it does. So like Google makes protocols and then puts them in the
Right,
browser
right,
like
okay.
immediately. All right, so that's what they do.
Okay.
Where's Johnsky? Is he still here?
He's writing the next.
Good,
HTTP.
perfect. He's gone. So we're also building this thing called ASP.NET Core Sockets. If you've seen our demos before at Build, it's a bad name, but it's a brand new library, and the whole idea is that we want to build kind of a low-level abstraction for connections, kind of like OWIN and middleware for sockets for low-level programming. So Kestrel.
How's that different from SignalR?
SignalR is built on top of sockets. Sockets is kind of the
okay.
thing that gives me access to a connection and bytes, and SignalR is kind of a thing that does RPC on top of that. So
Okay.
you get, any transport can offer a connection and abstraction, and then SignalR can run on top of that transport. And then we have plans to make things like MQTT work and AMQP and gRPC, and more acronyms that main protocols that you don't know about.
So that works because of this abstracting
Right.
stuff out.
So
You've got-
they write to this new abstraction, and then those things work on multiple APIs.
Okay, cool.
So Kestrel, and the goal is in 2.0, Kestrel is built on top of these abstractions, so you get a generic networking server on top of Kestrel without having to worry about it.
Let me ask
the
you a
HTTP.
hard question.
Yeah.
Here. Did you just re-implement WCF when we weren't looking? This is WCF.
With less soap though, so it's
Oh,
dirtier.
okay, all right.
So the whole goal, yeah. So we're also pulling out the parsers from Kestrel, so it can be used in any if you want to have your own server. We'll make everything pluggable because we're nice people. That's open source, and open source is good. All right, so let's do more stuff.
Oh yeah, this was quick.
Yeah, this is quick. So here's TCP on the left. So 3 round trips to do a connection. Here's TCP and TLS. And on the right is quick.
Just all these handshaking.
All the
things going
handshakes back and forth to make it reliable.
Well, I like
ACK,
quick.
SYNAC.
Quick takes 0 milliseconds. That's clearly.
It's that fast.
That's very
It's
fast.
that fast.
Okay.
Yeah.
I can't argue on the name.
How much time do we have left? I was going to show the
11
signal. So
minutes?
let me show the sockets
Yeah.
for a second. So I have a demo that probably doesn't work. So before I came here, I had to rebuild everything because everything was just failing for some reason. I don't know why. But it works now. I didn't close VS, so it must be working. I have 5 of them open, just so you can see. Can't touch them. All right, so here is, has anyone seen the new SignalR? Yes, one person, perfect. So here is new SignalR in all its glory. Like ASP.NET Core products, you call add SignalR to add services, and then you call use SignalR to actually use it. In the new one, we don't discover hubs anymore. You have to actually map hubs to endpoints. Hubs map one-to-one with actual endpoints. So in this model, use SignalR lets me add map hubs, which are good old hubs where you direct from hub and you handle like overrides of things, and you can call from the client using RPC back and forth, and you can do clients to all that invoke. So since we're Signaler, I have to show chat because chat is what the main thing is for Signaler. Does anyone use Signaler and not use chat? Not do a chat application? I don't believe you. It's always chat.
When people chat, sometimes it's almost like they're jabbering back and forth at each other. Sometimes.
That hurt. That hurt. Okay, so can you see that? You know what, let me zoom the browser. WebSockets.
You could do Control Plus. Or, I mean.
Oh, that was Command Plus.
Oh.
There we go. All right, obligatory
Apple Plus.
Signaler demo. 2 windows, pin 1 to the right, pin 1 to the left. Connect here. What? It's going crazy. Connect here, connect here. Say, hey, this is cool. I'm going to waste time. So that's Signaler working, WebSockets, all good. But under the covers, it's built on top of this socket builder. So that means that if I have a socket builder on top of TCP directly, it all still works. Signaler has no idea about HTTP at all. So at the core of it, if you see this thing called useSockets, so this is so think of socket builder as the abstraction. So I have this thing called Microsoft ASP.NET Core Socket Abstractions. And it has, similar to HTTP context, we have a connection context, because why not? And it has a feature collection, and this just probably go away. This is all temporary. Ignore this code. Don't look. It's not finished yet. But the whole idea is that this is the abstraction over, this is the HTTP context of sockets, of the sockets world. And I want to use this to build higher level things. So for example, here's the middleware. Here's the socket delegate. This is equivalent to middleware, the middleware function. So normally you get an HTTP request, and you return a task when you're done with that request. Same thing here. You get a connection context, and when that connection is over, you get a task back that represents the connection lifetime.
So the benefit for me is that this now works with the same kind of, it works the same way ASP.NET Core works, meaning that it's not a whole
same
separate
patterns.
world, same
Similar
patterns.
patterns, yeah. Same patterns,
Okay.
same ideas.
So can I use my ASP.NET Core stuff like logging and all DI? And
So the whole idea, so exactly. So you get logging, you get DI, you get those intrinsics in the system configuration, and you can get these new abstractions on for free. So if you look on context, I believe there is on the builder, you do get a nice service provider, right? Same model as the application builder. So if you look at the low levels of, so Signaler has no dependency on HTTP. If you look in, that's the wrong button. If you look at projects, Signaler depends on sockets common and Signaler common and sockets abstractions. And then we have a Signaler HTTP, which is the middleware, which is the HTTP middleware that represents the sockets, the Signaler wire up. Same for sockets. Sockets has this thing called an endpoint, which is basically like a piece of middleware that runs at the end of the pipeline. And if you look at, let me show a demo of this thing now. So in startup, I have this thing called useSockets. It has a route. I can say map this socket to this message endpoint. The endpoint itself gets a connection. I can add to my list. I can broadcast by doing a simple for loop over those connections and calling write async on them. I can read from the actual transport. So I get a transport object, and I can read data from it and write to it. So it's super simple, right? And if I run this sample,
I get to chat.
Yeah, you get to chat again, but without Signaler.
Okay.
So you can use this to build higher level protocols like MQTT, MQP. So the whole idea is that people will build libraries and stuff on top of this abstraction stuff, and so we can move around without having to worry about where it's implemented. So let's do sockets using WebSockets. Looks similar, but under the covers, this is just sockets on top of WebSockets without anything in between.
Okay.
So I could run this on top of any other abstraction without having to worry about the underlying transport. All right, so let's move on.
Cool.
Let's show more stuff.
Generic hosts, another cross-cutting.
I'm gonna hustle through this stuff now.
Yeah, because we still have help.
The demos are gone. Yeah, so a few more things we have for ASP.NET Core and beyond. Turns out our pattern for the host builder and the ISO service is a very nice pattern. People want to use our DI libraries, our logging libraries, our configuration systems, but they'll ASP.NET itself. So we're going to put that into a separate library and have a generic host for other platforms. So the Orleans guys actually want to use it for New Orleans. So New Orleans. That's pretty good. That's pretty good. That was unplanned. So, so yeah, the whole idea was that we want to have a generic API that is a different builder for arbitrary applications to wire up things like that.
Okay.
So one example of that is having a host that has a thing called a RabbitMQ listener. So you can add services, add RabbitMQ to your host, and then listen to messages that come in off a background thread.
Cool.
Same for workers. If you've ever used what's it called? Not Simple Batch. The name is the background task thing in Azure Worker, Azure. Someone help me. Azure.
So you can run a console app inside your app inside an app service. It's a
Web jobs, right? Web jobs. It's kind of like that. So like, imagine you had a library that was web jobs, but locally. And I believe the Azure WebJobs CK is actually runnable like on premise. So yeah, so it's very similar to that, but it's a more generic thing that does DI configuration logging without any first class support for those things.
cool. Health checks.
Health checks. So we have this library called health checks. If you've ever written a real service, you want to know when things are going down. So you kind of ping like URLs, you ping SQL, you ping, I don't know, Redis to see if it's up. We want to have a library that is an ASP.NET Core that is for health, that does health checks. It integrates with DI, integrates with like Service Fabric and Docker. So Docker has a first-class ping support for the containers that run in Docker. So we want to have that.
So Docker can like, if a container is bad, it can spin up a new container.
Exactly.
Or that kind of thing.
It can orchestrate.
So it allows Docker to ping my health check using that standard method, and then my thing will ping and say, yes, I've got
alive,
a database.
I'm healthy, I'm unhealthy, or I'm kind of healthy.
Okay.
There's an in-between state. It's kind of funny.
Healthier than
Yeah, healthier than, yeah. Okay. And there is support for System Web, so old ASP.NET. So current, not old, current ASP.NET. Other ASP.NET. 4x.
Full.
Yeah, full. I won't show it because I don't have much time left. I can show you time after we go through the slides. Okay, so this is an interesting one. We didn't do that much for RESTful things in MVC. It's kind of the base framework that gives you like all the primitives. So we have content negotiation and formatters. We don't have anything on top of that. So you couldn't, if you want to generate links to related entities in your MVC controller, you can't have to do it yourself. Okay. So we want to kind of figure out if there's a way we can have better first-class support for things like OData, GraphQL, JSON-LD, for producing those documents when you actually want to have APIs that are modern. The other thing that we want to do is get back to automatic proxy creation for clients. There's a thing called AutoRest that is there for the Azure people to generate their APIs.
Right.
And we want to like integrate that into our tool chain. So when you make an API for MVC, you can do add reference and then have it like generate proxies for TypeScript and C# and whatever language you want. Right.
I mean, is that using Swagger naturally?
Yes.
Okay.
So by default, imagine you had an API project, you get Swagger by default without having to worry about like adding Swagger or anything.
Cool.
So the whole idea is that we look at the REST guidelines of that. So there's a thing called the Microsoft REST guidelines that we released like a month ago. It has a whole bunch of documents about how to do REST, and people complain because it was terrible and blah, 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 blah. But it's pretty cool. So we read that, and we probably try to figure out how we can integrate more of those opinions into our stack so you can do that more often. And our developer called it COD. I don't know why.
Yeah, fire that developer.
Yeah, no.
Don't let developers name things.
They can name things. This is an interesting one that probably was an idea, like, I don't know, 2 days ago before I came to NDC. So the whole idea is that MVC shouldn't exist. It should just be controllers and
pull it down into
there's
the stack.
routing and there's middleware. And like there's nothing else. There's nothing in between, right? So you can route to anything, anywhere. The problem is today, MVC kind of runs at the end of the pipeline. So if you wrote middleware that wants to get to a route, you couldn't generate URLs to arbitrary parts of your web stack without being in MVC. So everyone has to either use MVC or you kind of lose, right? So you kind of want to have routing be an intrinsic, so everyone can just route to an arbitrary like controller or an arbitrary like delegate somewhere else.
Okay.
So we want to have routing be like bit into the actual stack deeper. And then filters are there because we had them before. But to be honest, they're pretty much like middleware. They're cross-cutting concerns that apply to an MVC framework. Instead of it being like for MVC, we could just have middleware and controllers.
And you already have filters as middleware available,
exactly.
right? So
right.
just
So
make it
it's kind
the
of
whole thing.
inching towards like making it just one thing, right?
Okay, cool.
We aren't taking away anything. Don't worry, just me saying stuff right now.
All right.
Yeah. Okay, I tried to get this demo, but I couldn't get it working. But there's a thing that someone else named called Klaxon. It's basically a way to start with MVC controller without having programming and startup CS. So we would, on the fly.
So I only write a controller.
So you write a
and it's-
controller, and that's your entire app. You don't worry about startup
It's a
CS
one
or
file.
it's a one file thing. And the whole idea was that you can use it to get started. It can be used as like the Azure Functions model for doing functions. So the whole idea is to keep the same concepts as ASP.NET, but not have you like lose those things when you move towards when you grow up from learning it to making a full app.
Cool.
We had this really cool API repo that actually did some cool stuff. Okay, this is
Oh, we're out of
crazy.
time. We
Oh,
can't-
this is super awesome. I had this stupid idea like 2 days ago.
Do you want to show it?
Yeah, I'll show it. Let me show it. Give me a thumbs up or a thumbs down afterwards.
Afterwards. I'll start right now.
It's not being recorded. That's good. So no one can see it besides you guys. So I was thinking, I like Razor pages. So what if, and I don't write applications. So I'm a fake like application developer. Okay, I wrote Java as my last application. It's been like 15 years. So the whole idea here was to take Razor pages and Razor and stick it into the client. So here's my controller. Speaker controller, returns IList, blah, blah, blah. Returns 2 speakers. And then here's the proxy that we create on the fly for you. That's TypeScript and does a promise, so it's like a task of whatever. It mirrors the actual controller action that you get back. And then there's this file, your view model for your page, which imports speaker and speaker model, and you get DI, so you can inject a nice speaker controller into your page model, and then like expose a property that will get used in the actual view. So onload happens when the actual view loads, and you call get speaker, and it just sets the speaker object here to the actual thing. And then here's the holy crap moment. We just port Razor to the actual client. So we would write a Razor parser and put it into the client side. And this actually doesn't it look nice? Or is it language? HTML. Better. So you would just do 4 of speakers, blah, 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 blah. And you wouldn't use Angular or React or Aurelia. This is better.
You'd use Fowler script.
Boom. Boom.
I think we're out of time.
Yes.
All right. That's he needed one person to clap. Now he's gonna do it.
Someone cares. I am doing this tonight. This is happening. Doesn't work yet. Yet.
Cool. All right. So you covered performance, native compilation. You covered standards. I don't think you actually showed anything simple the whole time.
Yeah.
Well,
Super simple.
All right.
Connections and pipelines.
All right.
No.
I think we're done.
Yeah. Awesome. Thanks, guys.
All right.